Hey everyone, Mr. Fransky here. We're going to round out our talk about inverse functions here in this video. So we're going to be able to find inverse functions from an equation, graph them, and prove inverses via composition. So let's jump in here and see what we got. So domain, range, one-to-one, those are things we talked about before, and mirror points, all things we're going to talk about in this video. So first thing we're going to talk about is finding the equation of an inverse function, f inverse of x. So I'm going to kind of go through the procedure down the middle here, and we'll try it with an example, and then we'll be able to do the other one using the same procedure. So first thing we're going to do is we're going to write it as y equals 3x plus 4. Okay, so if we have some kind of function, we're going to change the function to y. So write y equals. Okay, so we don't want f of x just because it gets confusing in there. Okay, first thing that we do then, so we just change that f of x to a y. Now, if we think about what inverses really do, right, if AB is on f, then what's on f inverse? BA, right? BA is on f inverse. So it just changes x and y's. So let's just do that. Let's just swap the x's and the y's. So x is equal to 3y plus 4. Okay, so we swap x and y. That's the second thing. Swap x and y. Now, in some functions, there might be more than one x. We're going to have that later on. So if you had like y equals 2x squared plus 3x minus 1, you'll put the y where all the x's are. So you'd have x equals 2y squared plus 3y minus 1. That's kind of tough to solve for y. This would be a parabola, which wouldn't have an inverse function anyway. So let's not worry about that for now. We'll get that in a later example. So after you swap x and y, the third thing you do is you solve for y. Now that might take some creative algebra skills. We'll see that in a later example as well. But we're just going to solve for y here. So I would subtract 4 equals 3y, and then divide both sides by 3. So y is x minus 4, all divided by 3. There you go. Okay, and the last thing you're going to do is change the y to f inverse of x. Okay, because if this is truly a function, then we should write it in function notation. So f inverse of x in this case is equal to x minus 4 over 3. Okay. Now this should undo whatever this function does. So let's try it. Let's do like f of 3. F of 3 would be 9 plus 4 is 13. So let's do f inverse of 13, because 13, 3 should be on the other graph. Well, 13 minus 4 is 9, divided by 3 is indeed 3. So see, it undoes what the function f did. That's really what inverse functions do. They undo each other. So let's take a look over here. F of x equals root x. So if we have root x, we're going to do our little procedure here. So we're going to change to a y equals root x. Now we swap x and y. X is root y. Now we solve for y. We square both sides. Y equals x squared. All right, so f inverse x squared. Now that seemed pretty easy, but we have to kind of think about this a little bit, because think about, what does root x look like? Root x looks like this, right? If you reflect that over the line y equals x, does it really make x squared? Well, it makes like half of x squared, right? So we have to be really careful here. The domain here is just positive numbers, so it would be bracket 0 infinity. Even though x squared can take any number you want, because it's the inverse of root x, it has to be just 0 infinity. Now this kind of comes back to what domain and range do for inverse functions. Domain and range just swap. They just swap. Okay, now here that's not very exciting, because my domain here is positives, and my range is also positives. So swapping them doesn't really make a lot of sense, right? Because it just ends up being the same thing. But let's say we had a function, I don't know, I gotta think of something real quick here. Let's say we had a function like, let's say it was shifted 3 to the right, but the same function. So this would be the square root of x minus 3, right? So if you do the switch x and y, and then you solve, you should end up with x squared plus 3 for your f inverse. So that would be up here. So let's see about our domain and range, right? Too far. That dealt with our flip over the line y equals x. So let's think about domain and range. Domain of the original one would be 3 infinity. And the range of the new one is 3 infinity. Right? So the domain and range really just swap. And the range here would be 0 infinity, domain here is 0 infinity. Right? So domain and range just swap when you're dealing with inverse functions. That's kind of the key to this slide. All right, so finding inverse functions, not too bad. So this one has some tricky algebra, but you got to know how to do it. I have people see these problems and are just like, well, I have no idea what to do. Well, try something. Let's see if we can figure it out together. So let's swap y equals x over x plus 1. Then we're going to switch x and y. We got two x's, so we'll have two y's. So we got x equals y over y plus 1. Now they're like, well, I have no idea what to do. Okay, well, let's try something. Let's see what we can do. I don't like fractions, so I'm going to get rid of it. So what I'm going to do is multiply both sides by y plus 1. Just multiply by the denominator, just like if you're clearing fractions and anything else, right? So now I have, let's distribute. So we have xy plus x is equal to, this is gone, just y. Okay? Now we're trying to solve for y. So I'm going to get all my y's on one side and all the x's on the other. So let's get the y's on the left. So we'll have xy minus y is equal to negative x. So everything that has a y is on the left, move the x to the other side. Now what I'm going to do is I'm going to factor out that y because it's shared in common. So I have y times x minus 1 is equal to negative x. And now we divide. Y is equal to negative x over x minus 1. Change it to an F inverse. Negative x over x minus 1. This is definitely going to show up again on homework, on quizzes, on tests, because people struggle with it, and it's something we need to do. Okay. Now, we could see this written a little bit differently if I had instead, how could I have done it? I could have done y minus xy at this point. So at this point, instead, I could have done y minus xy is equal to x. And then factor out the y, 1 minus x equals x. This just avoids the negative, so y equals x over 1 minus x. You can do it that way too. That basically is just applying this negative to the bottom and flipping both of them around. But it doesn't really matter, right? Either way, it would be correct. I like the way that I did it first. Doesn't really matter. Now, I'm actually going to show you how you can do this in Desmos. I'll keep those. I think I've got it pulled up here. This guy. So, what I have here is x over x plus 1, which is the function that we had. Now we know that we should be able to reflect over the line y equals x. Looks like 0, 0 is on this original, so that'll be on the new one. This part over here, though, is going to flip across and come over kind of down here. So we're going to flip it over that line, y equals x. I've got it on here. There you go. So if we graph the new one, I'm trying to remember what it was here. It'd be helpful if I had my keypad up. So it was negative x over... is it x minus 1 or 1 minus x? Let's graph them both and see which one it was. So over, and let's do 1 minus x. Nope, that wasn't it. It must have been x minus 1. Let's get rid of those. Uh-oh. X minus 1. There we go. All right, and as you can see, it is the exact thing just flipped over if I turn it off. Okay, so it's been flipped over the line y equals x. If 0, 0 is on there to start, it's still there. But everything from that was up here before flipped over to the bottom down here. Any point that's on this line is going to stay there, right? Because when you reflect over that line, it'll stay. Kind of cool. All right, let's go back to our slideshow here. All right. So now we're given a graph. I want to sketch the inverse function on the same axes. So we're going to use that same line we've been using. Let's change the color here. So we're going to use that y equals x line. Now there's one point on there that's going to stay exactly where it is. It's this point right here. It's like it's welded to that line, and I'm just going to like twirl that line around, and the function is going to kind of lay down, right? So these points are going to come over to here, right? Here we're getting further away. So it's going to be something like this. And it looks like we have the point 0, 1 here. So that's going to turn into 1, 0. That'll be over here. So we kind of come up through like that. And then it looks like we go away from the graph again. Okay. Now, if I had to choose the equation for this graph, it's probably just x cubed moved up 1. So x cubed plus 1. So if you were to switch that around, so if we have y equals x cubed plus 1, switch the x and the y. Subtract 1, take the cube root. Y is the cube root of x minus 1. So let's graph that on Desmos and see if that's what we get. And let's check it out. Here we are. So I've got x cubed plus 1, and then we have x minus 1 to the 1/3, which is the same as the cube root. That's that blue line there. Looks like what we graphed. Pretty cool. There we go. All right. Okay. So, proving two functions are inverses. So the key thing here is that they are undoing each other. Right? So, if we know that two inverse functions should undo each other, so if we plug an x value in to a function, f of x, and then we take the result and plug it into the inverse, what do you think we should get back out? So I start with x, it is somehow scrambled. F inverse should unscramble it. What should I get back? Well, I should get back out the x value I started with. So to prove two functions are inverses, what you have to do is you have to prove two compositions. So the way I just did this would be f of x was done first, and then we did the inverse on the outside of it. Make that inverse a little bit better. Okay, so f inverse of f of x should give us x. Okay, this is true if and only if f and f inverse are inverses. Inverses. Okay, and it should work the other way too. F of f inverse of x, I could write, should also give us x. Now we have to check both. So check both. You can't just do one and say it works and then you're done. You got to check both ways. If you get x out both ways, that means that these things are inverses. So let's try it with a function. So f of x and g of x, we want to show that they're inverses of each other. So what we have to do is we have to do f of g of x, and the question is it equal to x? We also have to do g of f of x, and the question is it equal to x? And if those are both true, then that means that these are inverse functions. Let's do f of g of x first. So I'm taking the g function, I'm going to put it inside that tiny little x. So it's f of, let's replace g of x with the cube root of x minus 1. So we're going to plug that into the f function here. So that is going to be the cube root of x minus 1 cubed plus 1. Well, the cube and the cube root, those are inverses, so they go away. So this is x minus 1 plus 1, which is x. Hey, that checks out. Cool. Now let's try the other way. G of f of x. That's going to be g of, I'll put the f of x inside, so g of x cubed plus 1. So that is the cube root of, that x is going to be replaced by x cubed plus 1 minus 1. The 1's go away. Cube root of x cubed, which is x. Hey, cool. Because we got x for both of them, therefore they are inverse functions. So f and g are inverses. Yay. Now I got one little cautionary slide here, right? Because you can kind of tell by looking, right? If you look at this, you're like, well, this one has a cube and a plus 1. This one has a cube root and a minus 1. But that's a dangerous trap a lot of people fall into. Let's take a look at the next one. This is a really common mistake everyone likes to make. So you got x squared plus 49. That's a square and a plus 49. We have a square root and a minus 7. Looks like those conceivably could cancel each other out, right? Let's do f of g of x first. F of g of x would be f of root x minus 7. So I take root x minus 7, replace this x. So we have root x minus 7 squared plus 49. Now, the majority of students in the nation are going to look at this and say, well, I just square these both. That gives me x minus 49 plus 49. Hey, they cancel out. It's x, right? Wrong. Don't do that, right? We cannot distribute a square across a subtraction like that. You have to FOIL, right? You have to FOIL this. So it would be root x minus 7, root x minus 7. That would give us root x times root x is x minus 14 root x. Yuck. This is not going to go away, right? Plus 49 plus another 49. That is not x. So the second you find out that it's not x, they are not inverses. That's all you have to do. All right. I think that's all I have for you. Love you guys. That's why I'm here. Have a great day.